Hello there, Marek is here. Today I'm going to talk about quadratic equations. So in this video we'll go from A to Z, discussing about how to solve a quadratic equation, of course reach to the factorized form. So what do we mean by quadratic equation? It's an equation where the variable, let's say it's x, it should be the highest power 2. So what is the general form of a quadratic equation? You will have the general form ax squared plus bx plus c is equal to 0. Now x, of course, is the variable. The highest power is 2. It's a quadratic equation. What about a, b, and c? A, b, and c represent the coefficients, which are, of course, real numbers. The first condition that you should be talking about is to have a value different than 0. Because if a was equal to 0, your equation will be transformed to bx plus c is equal to 0. Bx plus c is equal to 0. It's a linear equation. So whenever you have a linear equation, it's very simple to solve it. You simply have to say bx is equal to minus c, x is equal to minus c over b, and that's it. You have one simple single root. So in order to keep the equation in quadratic form, you should have a different than 0. So, but of course, c could be equal to 0, b could be equal to 0, or both b and c could be equal to 0. So whenever you have b, c, or both b and c equal to 0, you will have the incomplete form of quadratic equation. I'm going to take the incomplete form. I'm going to take, of course, examples related to each case, and we're going to solve them together. So let's start with the incomplete form. The incomplete form could be written as ax squared is equal to 0. This is the first case. So whenever you have b and c equal to 0, b and c both equal to 0. The second case, how do we solve this equation? Very simple. Whenever you have ax squared is equal to 0, you can simply say that it's x squared, which is equal to 0, so x is equal to 0, and this is the root. Now what about the case where I have, for example, c is equal to 0? Your equation will be transformed to ax squared plus bx is equal to 0. So here we have c is equal to 0. So how do we solve? Again, simple. You have x as a common factor, so whatever remains is ax plus b, which is equal to 0. So x is equal to 0, or ax plus b is equal to 0. X is equal to minus b over a. So you have these two roots. Now what about the third form, where you have b is equal to 0? Your equation will be ax squared plus c is equal to 0. So in this case it's b which is equal to 0. How do I solve? In this case you should pay attention. You simply say ax squared is equal to minus c, x squared is equal to minus c over a. You have two choices. Of course, you cannot say that x squared, which is equal to minus c over a, it's a negative value, because it depends on the sign of c and the sign of a. So if minus c over a was positive, you will have x is equal to minus the square root of minus c over a, or plus the square root of minus c. The second one will be plus the square root of minus c over a. What if minus c over a was negative, in this case you will have no real roots. We're talking in the real numbers, so no real roots. We're not discussing in the complex numbers. So these are the incomplete forms where b and c could be equal to 0, or simply c could be equal to 0, or b could be equal to 0. I'm going to take an example about each one and we're going to solve them together. So let's go forward. An incomplete form, let's say we have minus 5x squared is equal to 0. This one, it represents the form which is ax squared is equal to 0. How do I solve? Very simple. You simply say x squared is equal to 0, so x is equal to 0, and that's it. Now, what about the second form? I have 2x squared minus 6x is equal to 0. In this case, we have the similar form of ax squared plus bx is equal to 0. How do I solve? Again, I have 2x as a common factor. X minus 3 is equal to 0. So one of the roots is x is equal to 0. The second one, x is equal to 3. What about the third case? So in the third case we have 3x squared minus 8, which is equal to 0. Of course, it's the same thing as the previous form, ax squared plus c, which is equal to 0. So how do I solve it? 3x squared is equal to 8. X squared is equal to 8 over 3. x1 is equal to square root of 8 over 3. x2 is minus square root of 8 over 3. So you have two opposite roots. Now, similarly, when we have 2x squared plus 5, which is equal to 0, again, it's the form of ax squared plus c, which is equal to 0. In order to solve, I will take the same steps. So I will say 2x squared is equal to minus 5. X squared is equal to minus 5 over 2. I simply say no real roots because x squared, which is a positive or null value, it cannot be negative. So no real roots in this case. So we took an example of each incomplete form, and we discussed the roots, the existence of roots. Now, what about the complete form? What about the complete form? The complete form is when you have ax squared plus bx plus c is equal to 0, where a, b, and c, the three of them are different than 0. Now, in order to solve this equation, we should follow a few steps. I'm going to take you through the demonstration or the proof in order to reach and talk about the part where we can discuss the existence or the non-existence of roots. So the first step is to divide this equation by a. So I will divide this equation by a. I will obtain a over a, b over a, and c over a. Of course, 0 over a is 0, so a over ax squared plus b over ax plus c over a is equal to 0. Now, this form, which is x squared plus b over ax plus c over a, the first part, x squared plus b over ax, It's similar to the expansion of a perfect square binomial. I can say that it's similar to a squared plus 2ab. So I have to identify with a squared plus 2ab. Of course, a squared plus 2ab, whatever remains is plus b squared in order to talk about the perfect square. So I should find out what is the value of b squared and add it in my equation. So I will have to do a certain identification. I simply say I have x squared is equal to a squared. So x is equal to, x squared is equal to a squared, x is equal to a. And similarly, you will have to talk about b over a x is equal to 2ab. So we should find, in this case, the b that we're gonna add. So we have already x and a the same thing from the previous equation. So b which is in question, the b which is in yellow, b will be equal to b over 2a, b over 2a. All right, so this is the b which was in question. This is the b that I'm gonna of course add in my equation. So I will add b squared and subtract b squared as if I did zero addition. So my equation will be transformed to x squared plus b over ax plus b squared over 4a squared minus b squared over 4a squared plus c over a, which is equal to 0. Now, as you can see, here we have a perfect square. X squared plus b over ax plus b squared over 4a squared is the perfect square of which one? It's it's x plus b over 2a to the power of 2 minus, common denominator is 4a squared. So in case I'm gonna do the common denominator, so it will be 4a squared b squared minus 4ac. So this is the equation that I should find finally. This equation actually represents the last part where I can discuss about the existence of roots. So I'm going to take this equation, write it down again, and we're going to discuss about the existence or non-existence of roots. So the equation is x plus b over 2a to the power of 2 minus b squared minus 4ac over 4a squared, which is equal to 0. So as you can see, the first part, it's a perfect square. It could be positive or 0. 4a squared, it's a positive value. The part which I don't know anything about its sign, and it will decide the sign of my equation, is b squared minus 4ac. I don't know anything about b squared minus 4ac. So whenever I will write down this equation in this form, x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. The only part which is in question is b squared minus 4ac. Now b squared minus 4ac will be equal to a certain entity called delta, which is the discriminant. It's delta which will help me to discriminant. It's delta which will help me to find out if my equation has real roots or no. So, for example, what happens if delta is negative, which means b squared minus 4ac is negative? I cannot have the first part positive and the second part negative, so I will simply say when delta is negative, no real roots. What happens if delta is equal to 0? My equation will be transformed to x plus b over 2a squared is equal to 0. So I will obtain one double root, one real double root, which is x1 is equal to x2 is equal to minus b over 2a. Now what happens if delta was positive? If delta was positive, in this case, we will have two real distinct roots. We have two real distinct roots. How am I supposed to find its value? The value of each root. I'm going to take you through that step also. So this is when we have two real distinct roots. So what happens when delta is positive? Let's continue in the following page. If delta is positive, you will have x1 is equal to minus b minus square root of delta over 2a. x2 is equal to minus b plus square root of delta over 2a. All right. So in order to summarize, whenever we have an equation, a quadratic equation, which is in the complete form, ax squared plus bx plus c is equal to 0, you don't have to go through the steps that I did already in order to prove. You simply calculate delta. Delta is equal to b squared minus 4ac. It's a discriminant which is going to help you to find out about the existence or non-existence of your roots. Now, if delta was negative, you can directly say no real roots. If delta was equal to 0, so in this case you can say you have one real double root, which is of course x1 is equal to x2 is equal to minus b over 2a. And if delta was positive, you will have two real distinct roots. And of course x1 will be equal to minus b minus square root of delta over 2a. x2 is equal to minus b plus square root of delta over 2a. This is the whole summary of the complete form of quadratic equation. So whenever you have the complete form, this is what you should do. Calculate delta and check its sign. Negative, no real roots. Positive, two distinct roots, x1, x2. And if delta was equal to 0, one real double root. Let's take some examples. So I'm going to take a few examples and we're going to discuss about each one. The first one, x squared minus x plus 1 over 4, which is equal to 0. So for this equation, of course, it's a complete form. It's not incomplete in order to factorize easily. So this is the complete form. I will have to calculate delta. Delta is equal to b squared minus 4ac. What about the value of b? B is equal to minus 1 squared minus 4 times a is 1. C is 1 over 4. So you will have 1 minus 1, which is equal to 0. So if delta is equal to 0, you will have to say you have one real double root. One real double root, which is x1 is equal to x2 is equal to minus b over 2a. What is minus b over 2a? It's equal to minus 1 plus 1 over 2a over 2. So your root is actually 1 over 2. How do I find the factorized form? Very simple. Since x is equal to 1 over 2, it's a root. It means that x minus 1 over 2, it's a factor. And of course, in this case, it's going to be x minus 1 over 2 to the power of 2, because you have double roots. So the factorized form will be x minus 1 over 2 to the power of 2, which is equal to 0. This is how you get to the factorized form. This was the first example. Now, second example, let's say we have 2x squared minus 3x plus 4, which is equal to 0. Again, it's the complete form. A, b, and c are, the three of them are different than 0. You start by calculating delta. Delta is equal to b squared minus 4ac. What about b? B is equal to minus 3 to the power of 2. Minus 4 times a is 2. C is 4. So you will obtain 9 minus 8 times 4, 32. So you will have minus 23. Minus 23 is a negative value, which means you will have no real roots. Again, I repeat, we are working in the real numbers, not complex numbers. That's why we have to say no real roots. And of course, you cannot factorize this equation. It will remain in this form. Now, the third example, hopefully the one where delta is positive. So 3x squared plus x minus 4 is equal to 0. Delta is equal to b squared minus 4ac. So you will have b as 1 to the power of 2 minus 4 times a is 3 and c is minus 4. So it will be 1 plus 48. All right, it will be equal to 49, which is positive. So since delta is positive, I can say I have two real distinct roots, such that x1 is equal to minus b minus square root of delta over 2a. So it will be equal to minus 1 minus square root of 49, 7 over 2a, it's 6. So it will be minus 8 over 6, it's minus 4 over 3. x2 is equal to minus b plus square root of delta over 2a. So it's negative 1 plus 7 over 6. So it's 6 over 6 is equal to 1. How do I find the factorized form? Very simple. In order to write down the factorized form, you should say it's a times x minus x1 times x minus x2. So it will be 3 times x plus 4 over 3 times x minus 1, which is equal to 0. This is the factorized form. Even in the form where we had delta is equal to 0, the factorized form, you can say it's a times x minus x1 or x2 to the power of 2, which is equal to 0. Here a was 1, so I didn't take into consideration, and this is how you factorize each form. Alright, now I'm gonna discuss about a few remarks related to the quadratic equation. What happens if b is even? You will have to talk about the discriminant, which is the reduced form of the discriminant. The same thing, but the calculation will be a little bit different. And finally, I will give you some remarks in order to solve some equations where I can find the roots very easily and directly. So what about the reduced discriminant? So reduced discriminant, as we said previously, the discriminant is delta. So in this case it will be called delta prime. And delta prime whenever you have b which is even. Whenever you have b even. So when b is even, you will have delta prime, so ax squared plus bx plus c is equal to 0. Delta prime will be equal to b prime squared minus ac. What about b prime? B prime will be equal to b over 2, since b is even. So again, delta prime negative, no real roots. Delta prime is equal to 0, one real double root. In this case, one real double root. In this case, you will have x1 is equal to x2 is equal to minus b prime over a. And whenever you have delta prime positive, you will have two real distinct roots, such that x1 is equal to minus b prime minus square root of delta prime over a, and x2 is equal to minus b prime plus square root of delta prime over a. I'm going to take one example related to the reduced discriminant. So let's say we have minus x squared plus 4x plus 1. As you can see, b is equal to 4, it's even, so b prime is equal to b over 2 is 4 over 2, which is equal to 2. So I can calculate, of course I can calculate with delta, but I'm going to use delta prime. Delta prime is equal to b prime squared minus ac. B prime is 2 to the power of 2, minus a is minus 1, c is 1. So you will have 4 plus 1 is 5, it's positive. I will have two real distinct roots, such that x1 is equal to minus b prime minus square root of delta over a, so it will be equal to minus 2 minus square root of 5 over minus 1, so it will be equal to 2 plus square root of 5. x2 is equal to minus b prime plus square root of delta prime over a, so it will be equal to negative 2 plus square root of 5 over minus 1. The final answer will be 2 minus square root of 5. The factorized form, since I'm interested in the factorized form, so the factorized form, it's the same thing, it's a times x minus x1 times x minus x2. So you can write it down as minus 1 times x minus 2 minus square root of 5 times x minus 2 plus square root of 5. That's it. This was related to the discriminant, reduced form of discriminant. Now, final remarks, and we're going to finish this part. We're going to finish the whole part related to quadratic equations. So what are the most important remarks related to the quadratic equations? Whenever you have, of course, the equation is ax squared plus bx plus c, which is equal to 0. So in case you had, if a and c have opposite signs, directly you can say that this equation will have two real distinct roots without calculating delta. Two real distinct roots. So it could be that a question is, without calculating the discriminant, show that this equation has two real distinct roots. You simply check a and c. When a and c have opposite signs, you know that you will have two real distinct roots. What if a plus b plus c is equal to 0? Very simple. You will have two real roots such that x1 is equal to 1 and x2 is equal to c over a. I'm going to take some examples. And what if a minus b plus c is equal to 0? In this case, you will have x1 is equal to minus 1, x2 is equal to minus c over a. So, last two examples, and we're gonna finish this video. We have 3x squared plus x minus 4, which is equal to 0. And the second example is 3x squared minus x minus 4 is equal to 0. For the first one, as you can see, it is in the form of a plus b plus c, which is equal to 0. A is 3, b is 1, 3 plus 1, 4, minus 4 is 0. So you can say you have two distinct real roots such that x1 is equal to 1, x2 is equal to c over a, which is equal to minus 4 over 3, without calculating delta. In the form, in case you're interested in the factorized form, so the factorized form will be the same thing, a times x minus x1 times x minus x2. So it will be 3 times x minus 1 times x plus 4 over 3. Now, what about the second example? We have a minus b plus c, which is equal to 0. So 3 minus minus 1 is 3 plus 1. 4 minus 4 is 0. So we can say that one of the roots is x1 is equal to minus 1. As for the second one, x2 is equal to minus c over a. Minus c over a, it will be minus minus 4 is 4 over 3. So the factorized form, again, I'm going to write directly the factorized form is 3 times x plus 1 times x plus, minus 4 over 3 is equal to 0. Yep, that's it. That's the whole part related to the quadratic equation. We went from A to Z, calculating how do we solve the incomplete forms, the complete form by using delta, even delta prime, the reduced discriminant, plus whenever we have a plus b plus c is equal to 0 or a minus b plus c is equal to 0. And of course I took some examples. So this is a full course about the quadratic equation. I hope it was helpful. So I'm going to ask you to subscribe to my channel. You will be notified whenever I upload new videos. And I can also share with you my Instagram and Facebook account. You can contact me directly, or you can simply leave a comment below. I hope it was helpful, and see you next time.